In this video, I will show you how to solve a system of linear equations using your calculator TI-84 or TI-83 or any other version using the reduced row echelon form. So in order to do that, we will need to understand what matrices are. So here is a quick definition of what a matrix is. A matrix is basically a rectangular array of numbers or symbols arranged in rows and columns. Each element in a matrix is identified by two indices, the row number and the column number. Matrices are commonly used in mathematics, particularly in linear algebra, to represent system of linear equations, transformations, or data sets. The notations. The matrix is typically denoted by the capital letter, such as A, and its elements are written within brackets or parentheses. For example, the matrix A has the elements A11, which means the first element A11 is basically in the first row, first column, and then A12 means that element is in the first row, second column. A13 means it is in the first row, third column, and etc. This matrix in particular is a 3 by 3 matrix, which means it has 3 rows and 3 columns. So that is what a matrix is. The element in the first row and the second column is A12. So that element right there is in the third row, second column. And that is how we basically write our matrices. Now, how do we apply that to linear systems? So we're going to write an augmented matrix, which is basically the matrix that has all of the coefficients of the variables in order. We start with x and then y, and then if there is a z, we add z as well. But the augmented part is going to be adding the constant as well. So let me illustrate here. So if I wanted to say the matrix A, which is the augmented matrix for this linear system, is going to be all of the coefficients of x go in the first column, all of the coefficients of y go in the second column, and then all of the constant go in the third column. So basically it's like that. So for example, the first equation is going to yield 1 for a coefficient of x, -3 for a coefficient of y, and 2 for a constant. And then equation number 2, or row number 2, is going to be 6 for x, and then 5 for y, and -34 for the constant. Notice how your variables have to be ordered, and if any of these variables is missing, let's say that was missing, then we're going to replace the variable coefficient with 0. So don't skip it, don't put the 5 in here in that case. But in our case in here, we don't need to do that. So I'm going to say this is 6. Okay, now how do we use the calculator in this case? We're going to enter our matrix into the calculator, and then we're going to perform rref, which is reduced row echelon form, which is going to do all of the work for us, and we don't need to multiply any row and add any row to one another. It's basically doing the elimination method that we learned for this system, but it does it automatically for us. So the result is going to look like this. It's going to look like the unit matrix, which is, if it's a 2 by 2, it's going to be 1 0 0 1, and then it's going to give us a value for x and a value for y, basically, because those are our variables. So that would be our answer. So the answer is going to be x and y, as we learned in the past. So here is how we're going to do it. I'm going to grab my calculator, and then in order to put the matrix into the calculator, I will first turn it on, and then I will go to second matrix. So I will go to the edit menu, matrix, and then I will edit any of these matrices that I have here. So for example, this first matrix has 2 rows by 3 columns, so it's a 2 by 3. So what I will do here, I will go to, let's say, the edit menu first, and then I will go and edit C, for example, because that doesn't have any data there, and I will put 2, enter, 3, enter, and it's going to create the matrix space for me. So I'm going to enter my values. That is 1, -3, so I go each row first and then fill that row and then go to the next row. 2, enter. The next row, 6, enter, 5, enter, and negative 34, enter. Please don't use the minus sign, use the negative sign. Now, in order to access the rref, we need to second quit first, which is second mode, and then we go to second matrix one more time and go to the math menu, and now we're going to navigate to the function that says rref, not the A1, the B1. We're going to enter. We need to put our matrix here, which is I chose to be C, by the way. So that is a C actually. So I'm going to go second matrix one more time, and then I will navigate to matrix C and then click enter. It's going to go into that function. I will close the parentheses and click enter. And now I have my answers. X is equal to negative 4 and Y is equal to negative 2. So X equals negative 4, Y equals negative 2, or I can write it as negative 4 and negative 2, just like we wrote it before. So that is basically the way we're going to do it using the rref. I'm going to show you how to do this system of equations as well. This is a 3 by 4. It has 3 rows and 4 columns. The augmented matrix, I'm going to put it in D. It's going to be 1, 6, 3, 4. There is no need for that line, but I am used to it. 2, 1, 2, 3. 3, negative 2, 1, 0. Now I will go to my calculator, second matrix, and then I will go to the edit menu first, navigate to matrix D, click enter. This is a 3 by 4, enter. And then I will enter my values 1, 6, 3, 4. The second row has 2, 1, 2, here, 1. Oops. 1, 2, 3, and then the third row has 3, negative 2, 1, and 0. Now I entered all of the values. I'm gonna second quit or second mode to quit, and then second matrix, and then I will go to the math menu. I will navigate to rref or rref, and then click enter, and I will go second matrix one more time, navigate to matrix D, click enter, and then close the parentheses and then click enter one more time. So the solution is going to be X equals negative 2, Y equals negative 1, and Z equals 4, or I can write it as the ordered triple, negative 2, negative 1, and 4, and that will save you a lot of time. So that is how you're going to use your calculator to solve linear equations. Again, this works only for linear systems. It does not work for non-linear systems, so make sure you know the difference between the two. These are lines. All of the degree of the variables are 1. The other system has a degree that is other than 1. Sometimes you solve a linear equation with a non-linear equation. Sometimes you solve 2 non-linear equations. I just wanted to show you how to do the linear equations or the linear systems using the calculator, just in case you need it in the future. And I hope this video helped you, and I will see you in a different one.